We all kind of learn the basic rules of our planet's climate, right? It's hot at the equator, it's cold at the poles. Seems pretty simple. But what if I told you there are places on Earth that just completely ignore those rules? Today, we are diving into the climates that, by all logic, really shouldn't even exist.
I mean, think about it. When you picture the equator, your mind probably jumps straight to sweltering tropical heat, right? Dense, steamy rainforests, warm weather all year long. That's the textbook definition.
And on the flip side, the Arctic. It's gotta be a vast, frozen landscape locked in ice and snow for most of the year. It just makes sense.
And look, for most of our planet, those rules hold up perfectly. But some places are just rebels. And this isn't magic or some weird anomaly. It's the result of incredibly powerful local forces. I'm talking ocean currents and mountains that are so strong they can completely rewrite the global climate patterns we thought we knew. So let's pull back the curtain on our first big culprit in this climate mystery, the ocean. Its currents act like this massive planet-wide circulatory system, pushing incredible amounts of heat around the globe and basically engineering weather in the most unexpected ways. Okay, just look at this. It's wild. You've got Reykjavik in Iceland, way up there near the Arctic Circle, and its average January temperature is right around freezing. Now that's cold for sure, but totally livable. Now let's jump over to Yakutsk in Siberia, which is at pretty much the same latitude. Its average January temperature, a bone-chilling minus 38 degrees Celsius. How on earth is that possible? Well, the secret is the North Atlantic Current. Think of it as a massive river of warm water, an extension of the Gulf Stream that flows all the way from the tropics up into the north. It's basically a giant hot water heater for the entire region. It warms the air, giving Iceland and a lot of coastal Europe a climate that is way, way milder than it has any right to be. Seriously, without it, Iceland would be a lot more like Greenland.
And here's another paradox for you. Places like the southeastern United States or eastern China, if you look at the global atmospheric models, they should be deserts, but they're not. They're known for their hot, sticky, humid summers. And the reason? Yep, you guessed it. It's those warm ocean currents again, like the Gulf Stream, just pumping a ton of heat and moisture into the air that then blows inland.
All right, so we've seen what the ocean can do. Now let's talk about our second major climate architect, mountains. And these things aren't just passive, giant rocks just sitting there. They are active climate creators. They shape everything from how hot it gets to where the rain falls. So let's go back to that first question we asked. Is the equator always hot? Well, the Andes Mountains have a pretty definitive answer, and it's a resounding nope. Even though you've got that intense, direct tropical sun beating down, you can find actual glaciers and permanent snowfields high up in the Andes. It's a total contradiction. The secret here isn't about how far you are from the poles, it's about how high you are from the ground. It's called adiabatic cooling. For every 1,000 meters you climb, the temperature drops by about 6.5 degrees Celsius. The Andes are so tall, we're talking over 6,000 meters, that their peaks basically have a polar climate sitting smack dab on the equator. In this fight, altitude totally beats latitude. And mountains aren't just temperature controllers, they're the ultimate gatekeepers of water. Just look at the rain shadow effect. So you get all this moist air rolling in from the Pacific Ocean. It hits the Andes and has nowhere to go but up. As it rises, it cools, and it just dumps all of its rain. By the time that air gets over the peaks and starts to come down the other side, it is bone dry. And just like that, you've created the arid Patagonian desert. One mountain range, two completely different worlds. Okay, so we've seen what one force can do. But what happens when multiple forces team up? Well, that's when you get the truly bizarre climates, the places that defy all logic.
Welcome to the Atacama Desert in South America. In some parts of this desert, the average rainfall per year is less than 1 millimeter. It's one of the most hyper-arid places on our planet. I mean, nothing should be able to live here.
And yet, it does. In this impossibly dry landscape, there are these pockets of lush green vegetation, just blooming. How? Where in the world is the water coming from if it almost never, ever rains?
The secret, believe it or not, is fog. There's a cold ocean current offshore called the Humboldt Current, and it cools the air right above it, creating this thick, dense sea fog they call the Kamchatka. This fog rolls inland, but it doesn't really turn into rain. Instead, these amazing plants have evolved to literally comb moisture right out of the air. It's this perfect, weird recipe of ocean and land, creating life where it has no business being.
So from the driest hot desert on Earth, let's take a trip to the coldest place on Earth,
to find, well, another desert. The McMurdo Dry Valleys in Antarctica are one of the most extreme environments you can possibly imagine.
When you think of Antarctica, you just picture ice, miles and miles of it. But in these valleys, the reality is this barren, ice-free ground. It's a desert, and it happens because of a 1-2 punch. First, the mountains nearby create a snow shadow, blocking any storms. And second, incredibly powerful winds called katabatic winds, which are literally rivers of cold, dense air, come rushing down from the ice sheet and scour the valleys clean of any snow that manages to fall. A polar desert in the middle of a polar ice cap. It's just incredible.
So, what's the big takeaway from all this? It really shows that our planet's climate isn't some simple map where you go from hot to cold. No, it's this incredibly complex, dynamic system where local geography can create the most extraordinary results.
So let's just recap our climate mysteries real quick. We've got green Iceland, which breaks the rule that high latitudes are frozen, all thanks to warm ocean currents. We've got the icy Andes, which break the rule that the equator is hot because of high altitude. And we've got dry Patagonia, which breaks the rule that being near an ocean means you're going to be wet, and that's because of a mountain range shadow.
And here's the thing that really matters. These climates aren't just cool, weird oddities. They are incredibly fragile. They only exist because of this very precise, very narrow set of conditions. A specific ocean current running just so, a mountain range of a certain height, a very particular wind pattern.
And that leaves us with this final, really important question. If these unique environments are balanced on a knife's edge, what happens if one of those pieces gets moved? What happens to green Iceland if that North Atlantic current shifts or weakens? What happens to those fog oases in the Atacama if the ocean current warms up? It's a powerful reminder of the delicate, intricate, and absolutely extraordinary balance that makes our planet work.